Hello everyone, and a very warm welcome to Prakash Bindu Academy. यहाँ हमारा मिशन बिल्कुल सिंपल है, फिजिक्स के हर कॉन्सेप्ट को फंडामेंटल से एडवांस्ड लेवल तक मास्टर करना।
आज हम डाइव करने वाले हैं एक ऐसे टॉपिक में जो थोड़ा सा एब्स्ट्रैक्ट लगता है, इलेक्ट्रोस्टैटिक पोटेंशियल। बट ट्रस्ट मी ऑन दिस वन, अगर आपने इसे एक बार अच्छे से समझ लिया ना, तो ये एक सुपर लॉजिकल और हाई स्कोरिंग टॉपिक बन जाएगा। लेट्स मेक इट सुपर इजी टुगेदर।
हाँ, मैं जानता हूँ इलेक्ट्रोस्टैटिक पोटेंशियल इतना कंफ्यूजिंग क्यों लगता है। मैंने अक्सर देखा है स्टूडेंट्स को इसके एब्स्ट्रैक्ट नेचर, इसके साइन कन्वेंशंस और इलेक्ट्रिक फील्ड के साथ इसके रिलेशन में स्ट्रगल करते हुए। बट डोंट यू वरी, आज हम इन सभी नॉट्स को एक एक करके अनटैंगल करेंगे।
Okay, so here's our game plan for today. सबसे पहले, we'll build an intuition, a feel for what potential really is. फिर, we'll get into the real physics definition. उसके बाद, we're going to master the charged sphere, a hot favorite in exams. Then, we hit the JEE NEET exam zone. Or finally, we'll wrap it all up with the most important takeaways. So, let's get right into it.
All right, first things first. Let's take this invisible, abstract concept and make it, visible. We're going to use a really powerful analogy to help you literally see what potential is all about. So I want you to imagine a big hill. Just picture it. Now, the height of that hill, right? That's our electrostatic potential. And the steepness, the slope of the hill, that represents the electric field. Simple enough, isn't it? Let's dig a little deeper into this. Think about it. पानी हमेशा कैसे बहता है? Downhill, right? From a high point to a low point. बिल्कुल वैसे ही, a positive charge always moves from high potential to low potential. And the path it takes, the steepest path, is the direction of the electric field. Just like a map has contour lines connecting points of the same height, in physics we have equipotential surfaces that connect all the points with the same potential. See the connection? It's pretty cool. Okay, so now that we have this feel, this intuition from our hill analogy, it's time to translate it into the formal language of physics. Let's get into the real definitions.
So what is electrostatic potential officially? It's the work done, listen carefully, the work done by an external force to bring a unit positive charge from infinity all the way to a specific point. That's it. In simple words, it's all about energy per charge. और energy का सबसे अच्छा part क्या है? No directions. It's a scalar quantity, which makes our life so much easier.
And here it is, the core formula for a point charge. V equals kq over r. Now please, notice this. This is super important. Potential is proportional to 1 over times r, not 1 over r squared. That's the electric field. This is a classic mix-up in exams, so burn this difference into your memory.
Like I said, the superpower of potential is that it's a scalar. And what does that mean for you? It means no vectors, no components, no complex additions, just simple, straightforward algebra. V total is just V1 plus V2 plus V3. Easy. But, and this is a big but, the sign of the charge Q is absolutely critical. Positive charge, positive potential. Negative charge, negative potential. You have to include the sign.
Okay, let's zoom in on a topic that is a goldmine for exam questions. I'm talking about the potential due to a uniformly charged non-conducting sphere. You'll see this one again and again.
These three formulas right here, you need to know them by heart. Outside the sphere, it's simple. V equals kq over r, just like a point charge. On the surface, easy. Just replace the small r with the radius, capital R. But the real action, the place where things get interesting, is inside the sphere. Look at that formula. The potential there follows a parabolic relationship with distance. That's the key difference.
And that inside formula gives us an amazing shortcut, a fact that often shows up as a direct question. Ready for it? The potential right at the center of the sphere is exactly 1.5 times the potential on its surface. V center is 1.5 times V surface. Just remember that number, 1.5. It's a lifesaver.
And this graph just ties it all together beautifully. Look, at the center, r equals 0, potential is at its maximum value, that 1.5 times the surface value we just talked about. Then, as we move out towards the surface, it decreases, but not in a straight line. It follows that parabolic curve. Once you hit the surface and go outside, it starts behaving like a normal point charge, falling off as 1 over r until it becomes 0 at infinity.
All right, now for arguably the most important section. We've got the concepts, but how do we turn that knowledge into marks?
let's talk about the JEE/NEET exam zone, how to boost your rank, and, just as importantly, how to avoid those killer mistakes.
Look, you're preparing for some of the toughest exams out there, so you need to know where to focus your energy. And electrostatics is, without a doubt, a high-weightage topic. You can consistently expect 2 to 3 questions in both NEET and JEE Mains. That's a significant chunk of marks, enough to make a real difference to your rank.
Okay, let's talk about the traps. These are the silly mistakes that cost you marks. Trap number 1, forgetting the sign of the charge. We talked about this. Potential is a scalar, so the sign is everything. Trap number 2, confusing the formulas for E and V. Remember, V is 1 over R, E is 1 over R squared. And trap number 3, a big one, mixing up the work done by the field versus the work done by an external agent. They have opposite signs. Remember, work done by the field is negative delta U. Be careful.
So, if I had to give you one single rank booster formula from this topic, this would be it: the potential inside a non-conducting sphere. If you truly master this one formula, I guarantee you it will help you solve a whole range of questions quickly and accurately. This is your secret weapon.
All right, let's bring it all home. Let's do a quick recap of the most important points, and I'll leave you with a final thought to take with you.
If there's just one thing you take away from our session today, let it be this: potential is a scalar. It's about energy. Its sign depends completely on the sign of the charge. You master this simple idea, and you've already won half the battle, I promise.
So, keep practicing, keep visualizing, and stay focused. You have all the potential you need to ace these exams. Go out there and turn this concept into your scoring strength. All the best.